is Chapter 5, Lesson 4, Dividing Polynomials. In the previous video, we learned how to divide using long division. In this video, we're going to learn how to divide using synthetic division, and we will use the remainder theorem to evaluate a polynomial. In the process, we will add, subtract, and multiply polynomials. To do synthetic division, these are the steps involved. You will first write your polynomial with only coefficients, including all the zeros and the missing coefficients, in standard form, but you take out all the variables and the exponents. So all you have really are the coefficients. And then your divisor on the outside of the division box will have an opposite sign. So I'll show you an example and then you'll understand. Okay, in this example, we're going to take our polynomial here and we're going to write down all the coefficients, but none of the variables and none of the exponents. So the coefficient on this first term is 1. Then we have negative 14, positive 51, and negative 54. So we write down all the coefficients. Put an upside down division box here with space to write in underneath your variables or your numbers. And then we take our factor that we're dividing by, our divisor, and we basically find out what the 0 is to that divisor. Since the number is negative 2, that's what I put here. So now, to do synthetic division, you take your first term here and you drop it down all the way outside the box. Then you will multiply these two numbers together. That multiplication will go right there, the answer to that multiplication. So negative 1 times, or 1 times negative 2 is negative 2. That goes here. Next, I will add these two, add this column together. Negative 14, negative 2 is negative 16. Then I multiply. Negative 2 times negative 16 is positive 32, and that goes under the 51. I add the 32 and the 51, which gives me 83. Then I take 83 and multiply it by negative 2, which gives me negative 166, and that goes here. And then I add these two together, and that gives me negative 220. So in this problem, the question is, what is the quotient and what is the remainder? The quotient is all of these three, and this last part here is the remainder. So if I were to write it in polynomial form, the quotient is x squared minus 16x plus 83 with a remainder of negative 220. Quotient and remainder. Okay, that was brand new to you, so you probably want to see another one. So I have another example here. We'll take our polynomial here, write down all the coefficients. Coefficient on x cubed is 1. The x squared term is missing, so I have to put a 0 in for the x squared. Negative 57 for x, and 56 for the constant term. The number outside the division box will be the 0 to this factor, so that would be a positive 7. So I bring the 1 all the way down outside the box. 1 times 7 is 7, and then I add the column. 0 plus 7 is 7. Then I multiply the number outside times our divisor here. That gives me 49. And then I add 49 and negative 57. That gives me negative 8. Multiplying negative 8 times 7, I get negative 56. Adding the column, I get 0. So the quotient is x squared plus 7x minus 8. The remainder is 0. Since the remainder is 0, I know that x squared plus 7x minus 8 is a factor of our original polynomial. And that also means that x plus 7 is a factor of that polynomial. So we could say, there it is in factored form. Okay, now we're going to use synthetic division to evaluate a polynomial. So what we're looking for here is, given this polynomial, we want to know what is p of 3. This is function notation, and what it says is we're going to substitute 3 into the equation. So we're going to have 3 to the 5th minus 2 times 3 cubed minus 3 to the 2nd plus 2. We're going to calculate that. But we're not going to calculate it the old-fashioned way. We're going to calculate it using synthetic division. So we're going to put out our coefficients. The coefficient on x to the 5th is 1. X to the 4th is missing. X to the 3rd is negative 2. X to the 2nd is negative 1. X to the 1st is missing. And our constant term. Okay? Our number is 3. That's already the 0. There's no factor involved, so I'm going to use the 3 right here. So I bring down the 1. 3 times 1 is 3. Add the column. 3 times 3 is 9. Add the column. 3 times 7 is 21. Add the column. 20 times 3 is 60. Add the column. 60 times 3 is 180. Add the column. And I get 182. So this remainder right here is the answer to this problem. So when I plug 3 into that equation, I get 182 as a value. And you can check it in your calculator. Okay, here it is again. If I want to find p of negative 4, I can find this by synthetic division. So I'm going to take my polynomial here, write down the coefficients. So the 1 on x to the 5th, negative 3 for x to the 4th, negative 28 for x to the 3rd, x squared is missing, 5 on the x to the 1st term, 20 on the constant term. We're going to do synthetic division with negative 4. Bring down the 1, multiply by negative 4, add the column. 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 So what this tells me is that p of negative 4 is 0. So that tells me that if I were to graph this function, the graph would have a 0 at negative 4, across the x-axis at negative 4. That would be one of its crossing points. Okay, that's the end of this video.